Okay, Math 098, we're going to continue with Chapter 9, Section 2 with inverse functions. And since we just finished with composition functions, what we're going to learn here is the notation for an inverse. So if this is a function, its inverse, we tend to write the notation like this, where we take it to the -1 power. And what we'll learn today is if functions are really inverses of each other, the composition functions will cancel each other out and you'll be left with x. But in order to have a function have an inverse, it must be 1-to-1. But what does that mean? So you'll hear the phrase over and over again, or you'll read it in the book, of being 1-to-1, and that means there's exactly one y value for each one x value. Why is that the case? Well, if you remember, let me change colors. If we have a function, well then the x values cannot repeat. So what that means is if we have a 1-to-1 function, if an x value cannot repeat, then the y value also cannot repeat. So as we look at some of these problems, so we have f, g, h, and we have this table which I poorly wrote down. The table is supposed to look like this. So in the past we've done problems where we've said only the x values cannot repeat, which is the case for this first one. But what we also want to determine is if the y values repeat. Well, 2, 4, 0, and 3, they're all different. So all values are different. There's no repeat. All x values are different and all y values are different. You could have like an ordered pair that's the same, or like a y that's a 2 here and then an x that's a 2 later. So that's fine. As long as the x's do not repeat and the y's do not repeat, then yes, it is 1-to-1. Yes, it is 1-to-1. But if we look at the next one, I quickly am just looking through it, and g has a 9 repeating with another 9. So this is not 1-to-1. Oh, by the way, I tend to write out the words because I've written it out like this: 1, 2, 1. And I had a student say, "What's the absolute value of a negative sign?" I'm like, "No, this means 1, 2, 1." It's like a 1-1. So anyway, that's why I typically write it out. As I look at the next problem, and this is what I mean, it's okay that the x and the y share a same one, but as you look at the x's alone, 1, 2, 10, -5, there's no repeats. Then look at the y's, 1, 2, 10, -5, there's no repeats. So yes, this is 1-to-1, but if we look at letter D, I'm just finding until there's a contradiction here. Since the 2's repeat, this is not 1-to-1. And hopefully this is making sense. You may have even learned this in Algebra 2. So as we move on to graphs, because not everything is given to you as a set of ordered pairs, not everything is given to you as a table, you might be given graphs. Well, we learned about vertical line test. It was our test for functions. So let me just write that down. It was a test for functions. And we did the vertical line test because that indicated if x's repeat. If x's repeat. Well, if we want a similar test, so what sounds similar to a vertical line test, we want a test for if y's repeat. I hope it makes sense that you're going to do what's called the horizontal. And I'm okay if you shorten these to VLT, VLT, and HLT, horizontal line test. I did not give myself enough room. I'm good with both of those. So as you remind yourself, a vertical line test would be if you draw a vertical line down and if it only hits the graph once. So this first graph I gave you, yes, this is my handwriting, it passes the vertical line test because every vertical line only hits the graph once. So you might even make that note. It passes the vertical line test. But if you draw any horizontal line that hits, it hits twice. As soon as you find one horizontal line that doesn't work, I realize that the horizontal line test works up here because it only hits once. It doesn't hit at all above that. But as soon as you find one example that it fails, then we say it fails the horizontal line test. And therefore, this is not one-to-one. It has to pass both in order to be one-to-one. Because if it doesn't pass the vertical line test, it's not a function. So really no reason to move on from that. But if you look at the next one, try to come up with a vertical line or a horizontal line that hits more than once. And at least the way I drew it, it might not look very good because I messed up right there. But the intent of this problem was that every horizontal and vertical line will only hit the graph once. So it passes both, and because it passes both, therefore it is one-to-one. Yes, this is one-to-one. So look at the next one, just a linear function going down and to the right. Does it pass both? Yes, it does. So therefore it's one-to-one. So if you notice, it has to pass both in order to be yes. If it fails just one of them, it is not one-to-one. So as I look at my next graph, this is like a polar equation, which you don't really have to learn about this year. But this one actually fails both tests. It fails the vertical line test. As soon as you find one that it fails, you can stop. It also fails the horizontal line test. So this one fails both. And therefore it is not one-to-one. And it would be nice if instead of saying it passes both, it fails both, you actually tell me VLT and HLT. I know I'm not heeding my own advice in my examples. But the reason why that's nice is because sometimes students just accidentally hit the right answer. Like this one is not one-to-one. But it does pass, if I did the horizontal line test, this curve only hits everywhere at once. So it does pass the horizontal line test. And that's why I would like you to write that out. But this one fails the vertical line test. Because if I draw a vertical line test somewhere over here, we hit the graph more than once. So this one is not one-to-one. As always, if you feel like you're getting confused by something, or if maybe I said something wrong, feel free to write it down. Come to class, email me, find a way to fix the issue. I don't want you just to say, just move on. That's not what I want you to do. Okay, so let's get into the meat of what it means to be the inverse and why we do these tests. The inverse is switching X and Y around. And I know you've I'm pretty confident you guys did this even at the shortened Algebra 2 school year. So that's why we need to have a one-to-one function. Because imagine for a second that we switched X and Y around, but the Y's repeat. Well, if we switch the X and Y around with the Y's repeat, well, now the X's would repeat. And therefore, the function would not be a function. It would fail the vertical line test. So that's all we have to do for the inverse, but I want you to practice this notation as well. So if f is defined as this set of ordered pairs, then I want you to write f to the -1 power, and all you have to do is switch 3 and 4 become 4, 3. -2, 0 becomes 0, -2. 2, 8, because we're switching x and y, becomes 8, 2. And 6, 6, so that's kind of interesting that when you switch them, it's the same ordered pair. There we go. Now here's the thing is as I've mentioned before, is we have more than just tables, more than just ordered pairs, and more than just graphs. We also have equations. So as I show you this equation, just a reminder that f of x really means y equals. Okay, that's something you should know. And then the whole premise of the inverse is that we switch x and y. Well, now if I switch x and y, I get this equation. And now what I want you to do is to solve for y. So you may remember this from before, where your teacher just said to find the inverse, you switch x and y, and then you solve for y. It's a two-step process. Well, this problem is pretty easy because it's just subtracting 3 over. And I want you to practice this notation, the inverse. So what I want you to do is, instead of writing y equals, I want you to write that f inverse of x equals. As you take tougher math courses, your professors will expect you to do this. All right. And just one more thing, it's kind of tough to show you on a graphing calculator, but I'm going to try my best. Is if I go to y equals and type these two equations in, what do we have? X plus 3 and x minus 3. And I look at the graph. What you'll notice, though, is that the ordered pairs are switching around. Like 0, 3 switches around, it becomes 3, 0. Negative 3, 0 switches around to be 0, negative 3. Might be tough to see, but negative 1, 2 becomes 1, negative 2. Negative 2, 1 becomes 2, 1. So you can use your graphing calculator or Desmos to check your work. There's nothing wrong with that. Okay, but that's sort of where we're going with this. I think I'm going to stop the video here because I have 2 more examples that I want you to work through and I want you to really understand. So I'm going to stop the video here, and you can probably work through a good chunk of this assignment. It's the odds. And then when you get stuck, maybe you come back and you watch a second video. And I'll see you in that video, finishing these last 2 exercises.